right, that's orientation, guys. Up next, Monarch, are you on the call? I see you in chat.
I'm here.
Awesome. You ready to release the challenge?
Oh, it's my turn. Okay, yeah, sure, absolutely. Wait, can we do this in like half an hour? No, I'm kidding. I'm kidding, guys. I'm kidding.
I thought you were serious.
No, I'm not serious. My name is Monarch. I am the person who created the challenge talks. Sorry. If you guys have any questions about the challenge itself or about anything technical, I'm always available in the Discord. So if you are not on the Discord, you should be on the Discord because then you get to interact with moi. Not that that's important because everybody else on the Discord is actually way more awesome than I am. I have put together a really cool challenge today, and I have also put together a little bit of code for you guys. And it is a tutorial, it's a step-by-step, and all of it is copy-paste, but, and there's a big but here, don't just copy-paste, read the code. I'll walk you through it, but let's talk about what we're gonna be doing today. On the left-hand side of your details page, you're going to see this little tab called Kanban. I want everybody to head on over to Kanban, and there's going to be, for a few of you, there'll be unlock the Kanban guide. I want you to click that button, and when you click on it, this will show up. Never mind the little bug that you see over there with the text overflow. If anybody can solve that for us, I will give you a virtual cookie on Discord. But never mind the little bug over there. Let's talk about the challenge. There's, hi folks, the goal of the hackathon, getting started homepage, and then you have 4 tutorial tickets. And then there's a little ad for next week's hackathon. I'm going to go through the most important parts here. We're going to be building a chat room app with WebSockets. Show of hands, or maybe you can drop this in chat. I want to know who's worked in WebSockets before. Can you guys kind of drop this in Zoom chat if you worked in? Never. Leonardo said never. Okay. Anybody else worked with Socket.io or WebSockets? Okay, Kelsey has. Chetan is niet. No, negative, once. Zain is yes. Selena is yes. And most, okay, good. Great, that's good. That means a lot of you here are gonna learn some really mind-blowing stuff today. That's good. How many of you guys have ever built a chat room and not used WebSockets? Anybody built a chat room without WebSockets? Faith says no. Jessica says no. Zain and Naomi said yes. Okay, I know Zain also did WebSockets. Okay. Okay, cool. All right, sweet. Oh, that's cool. No, Google, I'm not talking to you. I said cool, not your name. Okay, good. Let's walk through it, and I will take it super slow. The goal of the hackathon is to build the chat room. We've given you sample code, and we've shown you how to get started with it right from step 1, which is initializing your project. But let's not get too ahead of ourselves. Let's talk about WebSockets. WebSockets. I'm going to stop sharing my screen. I'm going to do a janky old Zoom whiteboard. I hope everybody can see my whiteboard. If you can't, let me know. But here's and it's going to be relatively janky, but it's going to be enlightening as well. Here's your traditional Express server. And here's somewhere down here, you're going to have your traditional browser, right? And Express, it doesn't have to be Express. It can be any old server. It doesn't matter. I'm gonna take Express out. Let's just call it server. And how browsers and servers normally work is the browser usually starts by hitting the server with, let's say a post request. And then the server sends back the response soon after processing it. Let's say 200 OK, or not 200 OK, it could be 500. But this is generally how browsers and servers work. And this is how most of you know how to work with browsers and servers. Maybe you haven't done backend yet, but or maybe you haven't done front end yet, but you generally know that this is how servers and browsers kind of interact. Most of you know it. If you don't know it, that's okay too. You're gonna probably want to team up with somebody else if you've never done a fetch call before. Or maybe you want to spend a little bit more time this week if you're doing it solo and you've never done a fetch call before. But I think most of you are in pretty familiar territory when I say, okay, browser, server, there's a post going up, there's a 200 OK coming down. And quick question, if this is confusing for you immediately, can you please drop that in chat so I can adjust my walkthrough? Would be really helpful. If a lot of people are struggling with this level right now, then I'll slow it down even more, but please let me know in chat. Okay, so this is how you normally do things. Now, here's WebSockets. WebSockets, you have a server and you have a browser. Now, WebSockets, what you do instead is you have a two-way connection. And the two-way connection gets established. And now there's messages going up and down using what's called an emit. So before the server, and thank you so much for everybody who's answering the questions in chat for Tanya and Rahul. That's a great question. If you don't know what 200 OK is, that's a great question to ask right now. So instead of having a distinct post and that comes back with a response, what you have is a connection, a thread, kind of like if you've ever built one of those telephones with a string, those string telephones with solo cups, with plastic cups. That's kind of what a WebSocket is. It's a steady connection that's always alive, and that's important to know. It's always alive. And yes, the browser is sending stuff up, but the server can also send stuff down along the same line. It's the same connection, and it's a two-way street. So now instead of sending a letter up and waiting for the response, now it's a two-way street. You don't get responses. You're just talking, and the other person talks right back, if you get what I mean. So it's way more dynamic, and the server can send you data without you even asking for it, which is the real big feature of WebSockets. Is this the WebSocket can actually send you down data, and then your browser can react to that data. I mean, how cool is that, right? I mean, before all you could do is just hit the server with a get call and see if there's something new, and you would have to do that over and over again to see if maybe your website refreshed or if there's an update on the site you're on. But now the server can just tell you, hey, browser, here's some new data that came in, and then the browser can say, okay, and I'm going to react to that. Maybe there's a new person viewing my Google Doc, and because there's somebody new viewing my Google Doc, a little icon pops up on the top left or the top right and says, I don't know, pink hippo or blue squirrel, whatever you want to, those, everybody's seen those Google Docs where everybody's collaborating together and you can see different people's names in Google Docs. That's all enabled by WebSockets. And anytime you see a web chat, it's probably WebSockets that's being used. There's a bunch of there's a bunch of chat messages coming in. Okay, good. Okay, great. What does POG mean? I don't know what that means. I'm old or older. There's also 300, 400, 500. Okay, okay, good. So you guys are chatting. That's good. That's what Mintbean's all about, guys. You're all Mintbeans here. Oh, we have a plurinym now. We are calling ourselves Mintbeans. So Mintbean.io. That's you right there. You're a Mintbean. Mintbean Night doesn't work. Minty Bean was just bleh. So we're just Mintbeans. It's decided. So yeah, the server emits, browser listens, but the browser can also emit and the server can listen. So this kind of gets way more dynamic. How does this affect your code? Well, now all you have to do is listen for the other person's message. So what's going to end up happening now is if you have a chat application and you have multiple browsers, like so, and like so, what's going to end up happening is all the browsers are connecting to the server, and everybody is talking to each other using emits, up and down, up and down. Emits are happening. They're called emits in the code as well. And the emits are literally like, it is an emit. You're broadcasting data up and down the WebSocket. And if, for example, I'm going to use a different color, not pink, let's say green. So let's say this guy over here wanted to talk to this girl over here, then what this guy would do is he would emit a server request. He would emit a WebSocket message, and the server would listen to it, and the server would then, after that, you would have to write an extra line of code, but then the server can then be trained to emit that message right down to everybody who's listening. So as you can see, it's kind of like props being passed down in a very abstract way. If one browser is emitting data, then all the other browsers are receiving them. Erica is like, 1xx is, hold on, here you go away, you fucked up. I fucked, yeah, it's great. I like that. So here's, this is kind of how WebSockets works at a very high level. I hope I didn't confuse you all. If you're confused, I want you to say, I'm confused, and possibly give me more information about why you're confused in chat right now. And if you're thinking something, 100% somebody else is thinking it. I'm not a perfect human being. I probably screwed up something over here. Does this diagram kind of make sense for you guys? Yeah? No? So somebody said, how exactly does emit work without status codes? That is a fantastic question. Most people are yes, yes, yes. And does emit, okay, so David, I'll answer your question first. Emit, status codes are an HTTP thing. WebSockets are not, don't quote me on this, but they're parallel to HTTP. I don't think they actually use HTTP, or if they do, it's like a different protocol. It's probably TCP. I don't want to go into the weeds. WebSockets is different from HTTP. And what WebSockets does is it does away with the whole convention of 200 OK. Instead, it just sends you packets of data. So it's very different from HTTP. HTTP is only one protocol out of dozens that you can use in computer engineering to connect to computers. For example, UDP is another one, RTC is another one. Like the thing that we're using on Zoom, for example, we're on Zoom right now. Zoom does not use 200 OKs to send you data. It doesn't. It's streaming data. So what a WebSocket does is it just sends you data without the bureaucracy or stuffiness of a 200 OK. It just sends you data. So it just works like that. And Biprajit asked, does emit give and send data at the same time? No, emit only gives data. It doesn't return data. So it's a one-way, one emit is one way. So an emit doesn't, I think there's a way to get a response back from the server in WebSockets, if I'm not mistaken, but generally emits are one way. You emit one way, and then another emit is sent from the server to give you a response. So you're emitting an event, and then you're listening for an event. If people know how reducers work, then this is very similar to reducers, where each reducer has a separate label, a separate action, and each action is handled separately. If people know what reducers are, then that's kind of the same paradigm. It's called event handling or event-driven programming. It's an architecture, it's a type of computer architecture. And if you guys want to look into it, it's really cool, and it kind of stretches your mind and helps you think about software engineering as something more than just web development and building, you know, simple web pages. There's 1,000 ways to connect computers together. But I hope that answered the question. Good. Amir asked, so it's like an event listener will listen to a specific event, then notify all the other browsers about that. Yeah, you got it. Amir, you got it. Yeah, Amir, you're right there. You're exactly right. Let me stop sharing this, and let me start sharing my screen again. And Amir, you're so right. Maybe you've done this before. I don't know, but I'm gonna go into into details now. So there are 4 tutorial steps. If you don't see this, refresh your page. If you don't see all the tickets, refresh your page. There are 4 tutorial steps. And step 1 is we're going to create an application. We're going to create a Next.js application. Quick heads up, it is Next.js. Do not deploy it to Vercel. Okay, repeat after me. Do not deploy this particular Next.js app that I'm teaching you to build to Vercel. Vercel does not support WebSockets, right? Repeat after me. Vercel does not support WebSockets. That's one of the issues that the serverless world is dealing with. Serverless deployment mechanisms like Vercel and I think also Netlify don't support WebSockets because of their architecture. So what you want to do is maybe use Heroku for this time, or just this time around. I know they have free dynos. I think they still have them. AWS is a free tier, so you can deploy to EC2. I think DigitalOcean might also have a free tier, so use DigitalOcean. Do not use serverless deployments like Vercel or Netlify. This definitely won't work on GitHub, GitHub pages. It won't work on GitHub pages. But I would recommend using Heroku, just putting it out there. I should probably add this to the ticket. Maybe I will later. But we're going to use Next.js. And Next.js, you can create a Next app by using this command, npx create Next app. Then you cd into your directory, and then you do npm install socket.io, socket.io client, and then you do npm run dev. For the people who are looking at this and going, huh, what the hell? This npm install socket.io, socket.io client, that's both front end and back end. What the hell, Monarch? Yeah, so Next.js will let you install dependencies for both front end and back end together in one application. So it's a full stack application framework. So you install both of them into Next, and then you do npm run dev, and you can see it in action. So, oh, not this one. Here's the application running right now on my local. It's an ugly little application because I want you guys to bring your creativity to bear, but it does work. So I'm going to have another one right here. And this one can go here. And I don't know what this username is. I think that's an artifact of older code, but here we go. So let's set username Monarch on the left, enter. And let's set username, oh, I don't know, M&M on the right. And I can go on the left, I can go guess who's back. And it shows up on an M&M screen. And M&M says, yo, that's my line. And that's, they're 2 separate browser tabs talking to each other in real time. And all you have to do is 3 separate files make this happen. And all 3 of them are, I've sent you copies on the Kanban for all 3 of them. And I'll go into the Kanban right now and we can start looking at the Kanban. And let's go to step 2. Step 2 is we're going to make pages/index.js, which is this page over here is pages/index.js. And let's walk through the code together. I know I said tutorial, and now I'm giving you snippets. The reason I consider this a tutorial still is because I've given you a bunch of information inside the inside the snippet, and I'm going to walk you through it. So let me walk you through this tutorial. Standard React component. If you don't know what a React component is, I will also break down the useful parts for you. And if you haven't worked with React, that's fine. You can build this using vanilla JavaScript. It's okay. This particular example is in React. If you don't know React, I suggest you learn it. But if you don't know it, that's fine too. We have a few different variables. We have socket. We have is username confirmed. We have what's the username, what's the message inside the text box. And then we have message history. Message history kind of looks like this. So that you have username like Santa Claus, and then you have message like, yo, that's my line. Those are our states for this component. Now, the first thing we're going to do is we're going to put a use effect in and connect to the socket. That's the first thing we're going to do when the component loads up. Now, for connect socket, there's a little hack. This is a hack. I've explained it fully. I'm not going to go into it on the tutorial, but it's a hack. Just you can read the notes to understand why it's necessary. Maybe I'll go into it on this call. Let's start after the hack. So if there is no socket, if we haven't connected yet, then we create a new socket using WebSockets IO component. IO comes from socket.io, and IO is the WebSocket implementation that I'm most familiar with and I use the most. And it's pretty useful. It's pretty straightforward and easy to use. Using IO, using this, you get something called a socket, and then you have to train the socket on what you want it to do on different emitted events. So the connect event is something that comes right out of the box with Socket IO, and the connect event gets emitted or it gets triggered when a connection is made. And when we connect the app, we're just going to do console.log, and that's fine. That's just letting us know that the chat app has connected on connect. Disconnect also comes out of the box, and disconnect is just going to warn us, hey, maybe the server went down, the chat app got disconnected. But the interesting thing over here to note is that there's message, which is a custom event that we're using for our chat application. And that's something that when the socket in the browser, we're still in the browser, when the socket hears a message come in, it's going to add that to our history. So when I click, going back to our example, when I click submit on Monarch's end and M&M gets the guess who's back message, that message came from the message listener that's on this line over here. So this is where the browser is getting data from the server, like I described before. Questions so far? Any questions so far? Any M&M fans here? Does anybody listen to M&M anymore? M&M is like practically classic rock now. Can you go back to how they connect, please? David, sure, I'll do that. Danny, so it's pushing the message onto the history. Yes, it's pushing the message onto the history, Danny. Yes, that's right. David, I'll get back to you. Tanya said, can you explain more on the API part? Yep, Tanya, I'll get to the API in a second. As soon as I get to tutorial step, I think 3, I'll get to the API part. Ali Boss said, can I use WS? Yeah, you can use anything you want. This is just an example. This is not a mandatory process. So you can, if you want to use something else, go for it. If you want to use something that's not Next.js, you want to just use Express, go for it. Totally fine. So can I go back to how they connect? Sure. They connect simply by doing IO, and IO connects to the Socket IO is slightly opinionated. So IO will try and connect to the current server, the current URL, and try and get the, I think it's the /socket.io port is route is where it connects, I believe. Or maybe it's connecting to a certain port on the back end. I can't remember the underlying implementation anymore, but the underlying implementation is WebSockets gets exposed on a certain port or route on the back end, and new socket just connects to that route, if that makes sense. So this is magic. Like this line, you can treat it as magic for now. It just connects. You can read Socket.io documentation to see how Socket.io connects, but this line over here is what really initializes the connection. So this is the line that initializes the connection right here. I hope that kind of answers your question and gives you a direction in which to go. Then we have handle submit. Okay, so that's how we connect to Socket.io. And use effect, this is just bookkeeping for React. Here's the handle submit. Handle submit, this is the form submit handler, and evidence of that is here. There's a prevent default. So all of you guys who don't have any React experience, this is the front end form handler. Quick question over here, is Socket.io the server? Biprajit, Socket.io is like Express. It's not like Express. It's an add-on to Express or the backend. Socket.io is, WebSockets is the protocol that we're exposing. and we're talking over. Socket.io is a library. It's a full stack library. It exposes a front end and a back end. And Socket.io is a library that gives you WebSockets on both the front end and the back end. So Socket.io is the library, and Socket.io, the backend Socket.io library creates a WebSocket server. The front-end Socket.io library creates a client so you can talk to the server. So the front-end WebSocket.io version lets you talk to the backend. The backend Socket.io version lets you talk to the front end. Hope that helps. And if you look at the tutorial step 1, you can see that we installed Socket.io and Socket.io client. So we installed both. Anywho, coming back down to handle submit. This is where I think you guys are going to see the immediate difference. You guys are going to go, whoa, this is weird. We're preventing default, a little bit of bookkeeping over here, and then we're getting the message, we're getting the username from the form, from the state, and we're doing socket.emit message submitted, and we're blanking out the message on local. So when I go back here and I type blah and click submit, this line over here got triggered, socket.emit message submitted. So we're emitting from the browser. The browser is emitting a message submitted event that's then being caught by the server, which is really interesting. Usually you would do a fetch, like you would do a post call, but instead we're doing an emit. And usually with a post call, you would have to handle a 200 OK. Instead, we're not even handling the 200 OK. We're just sending it up, and we're going to wait for it to come back to us. And I'll show you how it comes back on the back end. But this is the socket emit event on the front end. If you guys want to kind of look underneath the hood, if you go to Network tab in Chrome and you go to WS, if you go to Network tab and you go to WS, instead of all, just go over to WS. That's for WebSocket. Here's the WebSocket stream in real time. So, well, you know what? I'll just maximize it. Here's the WebSocket stream in real time, and you can see the messages going up and down. This thing is a message submitted. This thing is a message. Here, I'll try and here is another message for y'all. So I'll click enter, and then it sent up a message submitted all the way up to WebSockets. So what happens is the up arrow over here says this got sent up, and then immediately after that, we received a message that was an echo of our message, which is actually how I'm adding the adding my own name back over here. Eminem's not talking here, I'm talking here, and yo M, enter. That yo M did a whole round trip to the server and got back to me, and you can see that evidenced over here. I'm sending up a message submitted, but I'm receiving a message. I'm sending up a message submitted. It says so right here, but I'm getting back a message from the server, and that's just an echo of my message that went out. So the server is telling me, yeah, I got your message, and that's when I added to my array. So that's how I've kind of built my app out. I got questions. So message submitted is the action type you're sending to the server. Yeah, that's right. Exactly, Julio. Message submitted is the action type that I'm sending to the server. Amir asked, I presume this message will first be validated, stored on the database, then sent as an emit. Amir, you should do that. My example app is very simple and doesn't have a database, but yes, you're right, exactly. And over here, there's a bit of bookkeeping over here. I mean, there's everything. Here's where this is just boring React stuff. I'm not going to go into the React stuff. You can definitely read through the code, but in the interest of time and not to bore people, I'm not going to go into how the React is set up. Heads up, there's another component called username field. I've put it into a separate file. So you need to do tutorial step number 3, which is we need a username field component, drop it into the component /username field.jsx file, and just drop it over there, and you can just copy paste this in. This has nothing to do with WebSockets. This is just the registration field up here, where I'm typing Eminem or I don't know, Julie. And that first line, that's the component for username field. So just so you guys know. So this username field is that. So moving on quickly then to step 4. This is the back end, and it's very tight, very small. I'll get into it in a second. Erica asked, how do you go about if you have different rooms? Great question. I can go into it at the end of this tutorial, and I can talk about that. And I think we can also just unmute ourselves, get into a group discussion, and talk about different architectures and project ideas. But we can do that right after project walkthrough is over. So Erica, excellent question. Zain, is it possible to do private chat using sockets? Zain, yeah, totally. You have to keep, you have to kind of do a little bit of bookkeeping in the end, keep an account of all of the sockets that are available to you, and then only send a message down the right socket. So every time somebody connects, it's an open connection. So the server might have 50 or 100 connections. So yes, you can absolutely do private chat, but you would have to do it with a little bit of more care in the back end. Maybe have a set or an array or an object that keeps track of all the sockets in memory. And then Zain said, because for that, we'll need the other person's socket ID. Yes, but in case the other person is offline and no socket ID is available, then how? See, we can talk about that after. And the right answer to that is you would have to store all the messages in a database of some sort, or maybe a Redis instance. You would save, and Selena's question is bang on. You could save messages in the database. I don't, but you could. And to answer Zain's question, which is, well, what if somebody goes offline and comes back online? Zain, that would be implementation details. You would have to create a separate event. Maybe on Connect, you send that person their private messages. But not going to go into that. Not going to go into details. Because that's, well, you guys gotta, you guys have a hackathon to do. So I'm not going to go into too many details over here. All right, so here's the server. This is more details about the hack that I did for Next.js. I decided to do Next.js because it's easy and it's brilliant, really. It does have some limitations. I'm not going to go into exactly why this file exists, but let's go to the interesting part. First things first, if the socket server isn't started up, if the WebSocket server isn't started up, then this statement runs first. It creates a new socket server. Then it creates a handler for a connection. So when somebody is connected, their socket becomes available. So when somebody connects, a socket becomes available, and this is the part where the socket is user specific and IO is global. And you can take that socket and you can store that somewhere. So to go back to Zain, you can store that somewhere. Not going to go into all that, but the socket is very specific to a specific browser. And you create handlers for that socket. So you have message submitted. When a message is submitted, then this handler triggers. So in the front end, when I say yo M, then I'm sending that up with a message submitted event that triggers this handler over here. And the first thing we do is we echo the message back to the user with a message, and then we do a broadcast to everybody else. So notice what's happening over here. I have to send 2 emits. One is to current socket, the other is to everybody else. And that's what socket.broadcast.emit does, is socket.broadcast.emit is specifically for sending information to all the other people. Socket.io is wonderfully designed. It's very convenient. It takes a little bit of getting your head wrapped around events and emits, but it's really simple and it's just really nice. It's a game changer. More people should know about WebSockets because it's so easy to use. But yeah, io.onConnection, when you connect, you can do stuff like console.log on connections, for example. So you can also do that stuff. But all we're doing right now is socket.on message submitted, emit a message back to the socket, and then broadcast the message to everybody else as well. That's how I'm getting back a message. So message submit goes up, message comes down, and message comes down for everybody. And then I'm setting the socket server IO on the res object. This makes the socket available externally. And it kind of just makes it available in general. Maybe there's an inaccuracy over here. I think this line, res.socket.server, is the actual thing that's making it available externally. This might be inaccuracy on my part, but this thing is important so that this line is important so that our next server remembers that a socket is open. And this res.socket.server.io is the same thing that's being referred to up here. So on the response object, is there a socket server IO? If yes, then server's already started, don't do anything. If we haven't made that socket available, then make that socket available. And that's it. And then you just send back an empty 200, and that's just for the hack. You put this inside the pages/API/chat file, and pages API chat, anything inside pages/API is actually a backend endpoint for Next.js. So Next.js is opinionated. You should read up a little bit of documentation on Next.js, how it likes its pages to be declared. It's really interesting and it's nice. Pages itself is going to contain all of your pages. Anything inside API gets exposed from the backend as an API endpoint, like an Express. That's pretty much it for the backend. I have a question from Tanya. Is broadcast optional? Like, if we don't want to message everybody, then do we use something other than broadcast? So is broadcast optional? Like, if we do not want the message to go to everyone, just go privately to some people, then do we use something other than broadcast? Yes, we do. So Tanya, the answer to that is the same answer to Zane's question, and it's the same answer to Erica's question. So yes, you can. And the way you do that is this socket is very specific. You know what? Let me open up my VS Code. And let me just open up the socket. Where's chat? So if we look at chat over here, what you're going to do is on connection, I'm in the backend now, mind you. On connection, I'm going to take the socket, and that socket, I'm going to save that somewhere. So let's say const sockets equals so. Then sockets, let's do sockets some random value equals socket. That's how you save the sockets. That's how you save the sockets inside memory. Does that make sense? Does that kind of make sense? And does that kind of give you a handle? Like, now you can build logic to see what the key is. Like, this would be maybe rec.user.id would be on sockets after you create user authentication maybe. So sockets can be stored by user ID. Sockets can be stored by random number. Socket can be stored by time. And then you can just, you can just decide that at some point in the future, you can just do, let's say, socket.on private message only for Monarch. Then I would do sockets Monarch's ID. So const Monarch socket is sockets Monarch's ID. And then I can do Monarch socket dot emit message chemistry. You could do something like that. Great. Salvador says he's clear. Erica.
Can I just?
Yeah, sure. Everybody, feel free at this point. We can get into Q&A now. I think walkthrough is over. If you guys have any questions, yeah, totally, yeah.
Yeah, so talking about the same thing that we just did about the Monarch socket over here. Uh, so do we need to like create specifically for if suppose if there's like 1,000 people who are chatting together on the same website, say, and everybody has a different chat room. So how would we handle that then? Like
Great
how
question.
it is for like suppose um give you a real life example, suppose Insta chats or the Facebook chats. So they really don't know the specific person who's chatting over there, right? So there are like thousands of people who are chatting to other 1,000 people, and there's like a complete chain, a tree kind of structure that goes along.
Yeah,
So how would we handle this thing?
great question. So how you would actually handle it is, I'm just going to comment this out. How you would actually handle it is when a message submitted comes through, this message object right now, message only has username and message. That's all it has right now. But it could possibly have a from ID, a to ID, a chatroom ID inside the message body itself. And then over here, what you can do is step one, check if the user in from ID is allowed to message the user in to ID. Step two, check if the user in from ID is allowed to message the user in to ID, but inside the chat room specified in chatroom ID. I'm just making a contrived example, but this is stuff, this is where your own business logic starts coming in. And let's say let allowed equals true. If db.get, let's say db users.get to ID is allowed to message. I'm just going to cheat and I'm just going to make like pseudocode, but whatever. From ID. Then you would do socket dot emit message. Well, then you would do sockets to ID dot emit message.
Yeah, now I get it. Yeah. Thank you.
Yep. And chatroom ID, channel ID, all of that can be set in the message. And if you set it in the message, then you'll have to validate it in the backend, of course, but you can validate whether a user is in a certain channel, is allowed to be in a certain channel. All of that can be done using business logic after you understand how the IO object and the socket object kind of work together. When you realize that the socket object is specific to a user, then that's at that point you kind of get it. So Erica, did that kind of answer your question? So instead of private message only for Monarch, instead of having the channel ID there, I would have the channel ID inside the payload, not inside the event name. Great. Amir said, can we use GraphQL and its subscriptions, or Socket.io is a must? I mean, if you really want to, you could use, wait, that's a good question. I'll allow it. There's nothing that says you specifically need to use sockets. And I think it'll be easier for some people to do just put and post and get, like what they call a polling strategy, where you're just polling the server, you're just constantly hitting the server with gets. You could do that. You won't learn much if you do that polling strategy. But GraphQL subscriptions, yeah, I'll allow it. Sure. Amr, great question. So Socket.io is not a must, but it's a learning hackathon, and Socket.io is something that is kind of really cool. But yeah, totally, man. If you want to use subscriptions, go for it. Any other questions? Open your mic if you want to ask, and ask me if you'd like, or drop it in chat. I'll give it 30 seconds. It feels so weird to actually wear headbands these days. My hair's getting long. Like I actually have headbands. Like what? Hairbands. Any documentation or links that you suggest for basic studies? Socket.io's website is great. Let me, yeah, just go to socketio.com. And here's socketio.com. You can go to learn and click get started. And this is the easiest way to do it. So all of your questions about persistent user ID, persistent messages, all of those are answered over here. So you can see the message, content from to, you can see all of that. And it'll go into way more detail than I did because I just gave you guys a super basic example here. And maybe some of the things I said are not best practice. So if you look at learn, you'll be able to learn WebSockets here. Besides using WebSockets and the method Amir mentioned, how would we go about implementing a chat function? Besides using WebSockets and the method Amir mentioned, how would we go about so Matthew, can you open your mic up and maybe we can discuss the question?
Yeah. How's it going?
Good, man. How are you?
Good.
Are you asking are you asking for an alternative method other than WebSockets, other than GraphQL?
Right. At the beginning, you said that you asked how many people implemented a chat application without using WebSockets. I was wondering what other methods you were referring to.
The browser can do a get call or get messages every second, every 2 seconds.
Gotcha. Okay, that answers it. Thank you.
Yep. Abel, what do you mean by threads ? Actually, somebody also mentioned threads. They implemented it using threads. I was confused by that as well. I think it was threads. Where's threads? Somebody said threads up there and I got confused by threads. Zain, but Zain left. Zain, he left. Okay, but he's the one who said he implemented it using threads and I have no clue what he meant. Okay. All right, great. Let's call that a wrap. We have coffee and code hours as usual. Code mentors are going to be around. Navi's going to get into all of that. But while we're here, I got to tell you, you guys should sign up for the next hackathon right now, and that way you won't forget it. The next hackathon is coming up. Here's how to code a chat room, Kanban. At the bottom, how to code an action game. Our game hackathons are probably one of our most famous, not yet. Maybe we are getting famous actually now. Our game hackathons are actually our most popular hackathons, and we're going to build an action game. There are multiple ways to do it. You can do it using Phaser.js. I recently discovered Matter.js, and Matter.js is just intense. Like, it is nice. Matter.js is probably the way I would build an action game now, and not Matter.js. And it's just super nice. And here's Matter.js doing what it's good at, and it's just really nice. And this is how a lot of people make a lot of money just building Matter.js things. Like, it's just impressive, and it's so easy to build. If you can get into Matter.js, you can do wonders for your own portfolio too. Imagine having this little thing on your portfolio. Like, how cool is that? Anyway, that's me.